Hi, this is Mr. Beiter, and these are the notes on matter. First, let's start with the words to know for this unit. Take a moment to pause and write these down in your notes. When you finish with this page, move right along to the next page and write these down as well. In this unit, we'll be learning about what matter is, what are physical and chemical properties, what is a characteristic property, how matter is classified, how can mixtures be separated, and how to read a solubility curve. To start off with, let's talk about matter. What is matter? Well, matter is anything that has mass and takes up space. That includes anything from galaxies to water to gases like this chlorine gas in here. There are some things that you might think of that are not matter, such as light, sound, and heat. Those are forms of energy, which is not matter. There are two kinds of properties. There are physical properties and chemical properties. And all types of matter have these properties. Some types of physical properties are color, solubility, boiling point, density, and magnetism. These are properties that you can observe without changing what it is that you're looking at. You can look at gold and see that it has a luster color, that it's shiny. And you can see that without changing gold into something else. Same thing with boiling point. We can find out the boiling point of water is 100 degrees Celsius without changing water. It can stay what it is. Chemical properties can only be observed by changing the substance into something else. Examples of this include tarnishing, rusting, oxidation, flammability, combustion, and chemical reaction with other substances. So if you consider iron being exposed to oxygen and rusting, making iron oxide, you have made something different. You've changed that substance from one thing, iron, into something else, iron oxide. So you've changed the substance. Same thing if you're doing flammability. You burn something, like you light a piece of paper on fire, you're going to end up with something new. It's gone in one direction from one substance to another. When you change something, that means that it is a chemical property. Some properties are characteristic properties, and these can be used to easily identify a substance. Density is an example. Gold always has a density of 19.3 grams per milliliter. It's always that. If you measure something and it has a density of 19.3 grams per milliliter, it is almost all the time going to be gold. Same thing with boiling point can be used to identify what something is as well. With few exceptions, water, if at standard temperature and pressure, will boil at 100 degrees Celsius. So if we have something that boils at 100 degrees Celsius, it'll probably be water. Electrical conductivity is another example that we can use to identify what something is. Now, scientists like to classify things. They like to take things and sort them and put them into piles. Same thing with all of matter. So everything in the universe that is matter, we can sort. Matter includes two main areas. We have substances with a definite composition, and we have mixtures of substances. Pure substances include elements and compounds. Elements are anything that will be on the periodic table. Compounds are chemically combined elements. So a compound is two or more different elements put together. Those are the only two things that will be substances. Mixtures, however, have variable composition. They're different things mixed together. They're not chemically combined. The two types of mixtures are homogeneous and heterogeneous. Homogeneous mixtures are also called solutions. The element is the simplest form of matter. You can't break it down any further. Compounds can be broken down chemically into elements. A heterogeneous mixture is not the same throughout. You can see the pieces and you can find more substances in one place than another. An homogeneous mixture is the same throughout. It's almost always a solution and you can't see the pieces. Here are some examples. Here's gold. It is an element, has a symbol AU, and this is a compound. You notice that it has different elements. It has sodium, hydrogen, carbon, and oxygen, and they're chemically combined. This is chocolate chip ice cream. This is a heterogeneous mixture. You can see these pieces in it, and we could take those pieces out if we wanted to. That's how we know that it's a heterogeneous mixture. It's not mixed very thoroughly. Iced tea over here is a solution. It is the same throughout. If we let it sit, nothing will fall out of it or precipitate out. It will stay a solution. Now, there are ways we can separate heterogeneous and homogeneous mixtures. We separate them using their physical properties. Filtration is used to separate by size. We can use a filter that'll let smaller pieces go through and then larger pieces are left behind. Evaporation, you can separate a solid that is dissolved in a liquid by adding heat and turning the liquid into a gas. Magnetic attraction, you can use a magnet to pull out magnetically attracted substances. Distillation, you separate two types of liquids by heating them and turning one of them into a gas. The other one would remain a liquid, and that would separate them. Here are some examples of those different methods. Let's take a look at these examples using a solubility curve of salt and sugar. The question here is, how many grams of sugar will dissolve at 20 degrees Celsius? Well, to answer this, we need to find out where the temperature scale is here. We go from 20, and we go up to the sugar curve here, and we see, we go across, it's 200 grams. At what temperature will 300 grams of sugar dissolve? Let's go to 300 grams here, go across, we hit the curve, and then we're going to go down, and we hit about 64 centigrade is when that much sugar will dissolve in 100 milliliters of water. This concludes the notes for matter.